Hi, welcome back to my statistics class. So today we'll talk about the property of sampling distribution of proportion. Okay, so for the sampling distribution model, we have mu proportion equals to I'm sorry. The mean of the sampling distribution proportion equals to the proportion, and the sigma equals to, which is the standard average, equals to the success rate times the failure rate divided by n and take square root of it. So remember Q equals to 1 minus P. For example, you're given the proportion is 0.23. If P equals to 0.23, so the failure rate equals to 1 minus 0.23, which is 0.77. Okay. And I want you to distinguish the sampling distribution of mean, which is the sampling distribution of mean. We use the notation of x bar equals to our mu, and then sigma of x bar equals to what? The standard deviation divided by square root of the sample size. Whereas the sampling proportion equals to the square root of the success rate times the failure rate divided by n. Or you can write it in this way. P times 1 minus P, which is our Q, over n. Okay, so the normal model is an appropriate approximation for the sampling distribution property if the following condition holds. First of all, as always, independence. The second part is randomization. But for the sampling distribution of proportion, we care about the success and the failure condition, which means you should have at least 10 success and 10 failure in your data. That means M, the sample size, times the success rate P should greater than or equals to 10, and the sample size times Q, or you can say M times 1 minus P, also greater than or equals to 10. So suppose 60% of the college students are either very satisfied or completely satisfied with their online shopping experience. You decided to take a nationwide random sample of 2,500 college students and ask if they agree. Is it reasonable to use normal model for the sampling distribution of the sampling proportion? Okay, is that reasonable? So we need to check three conditions. One, is this independent? So since they asked 2,500 different college students and each one is not going to affect each other's results. So yes, independence. And they given you the, hey, this is a randomization experience. So yes. So now we need to check the success and failure condition, see if they met this. So we know that, hey, this is totally 2,500 students, and suppose the proportion, what's the proportion of all the students are very satisfied with their online shopping experience? So the proportion is what? 60%. So that means it's 0.6. So now the success rate would be n times p equals to 2,500 times 0.6. So this is equals to what? Let me use a calculator. This is equals to 1,500, which is greater than or equals to 10. So that means, hey, this is greater than, we can use it. But we still need to check the failure rate, which is m times q. So if the success rate is 0.6, so the failure rate should be 0.4. That means 40%, presumably 40% of the college students are dissatisfied with the online test. So this is equals to 1000, which is also greater than or equals to 10. So that means this is also satisfy the success or failure condition. So that means, yes, we can apply it. We can use a normal model to estimate. So find the mean and standard deviation of the proportion of the survey. Okay, so now take a look. Our mean of our proportion should equals to the proportion, which is 0.6. Now, what about the deviation? Standard deviation, also called standard error, which is equals to the square root of P times Q over the sample size. So then we have P is equal to 0.6 times 0.4 divided by N is equals to 2500. So let's say we have square root of 0.6 times 0.4 times, and then divide divided by 2500 and square root all of them. Should be 0.0097, let's say 98. So that would be our standard deviation of the proportion. So what's the probability that the sample proportion of 2500 college students who agree is at least 57%? Okay, so since this is the proportion, so we let P hat be the sample proportion of the 25 college students. And from the previous condition, we already checked it. We can use a normal model to estimate the sampling distribution, right? So we know that this normal model, P hat, is going to follow the mean, the mean of what? 0.6 and the deviation of 0.998. So if there's a graph, this is going to look like with the center of 0.6, and then one standard deviation would be what? 0.6 at 0.998. Let's say this is approximately 0.001, because it's easier for us to calculate. So we have a 0.1 with one standard deviation. Two standard deviation was 0.62, and then subtract one standard deviation, we have a 0.59. Two standard deviation is 0.89, and this is 0.57, and this would be 0.63. So this totally should take up 99.8% of the area within 3 standard deviation. Okay, but this is not they asked you. They didn't ask you to draw the model. They asked you, hey, what would be a student at least 57% to agree? So now look at the graph. Let me erase this. At least 57% agree, which means this part, right? So remember 57%. We just calculate that. 57% is in the 3 standard deviation, should be more than 99%. So now let's use GeoGebra. So we know that the mu equals to 0.6 with the sigma equals to, let's be more accurate, 0.0098. And then we want x greater than 57, this way. this way, greater than 57, and see, look, the probability of that would be 99.89, which is what we expected, right? Because this is greater than the third standard deviation. So we have, p hat, the probability of p hat greater than or equals to 57% equals to 0.9989, which is 99.89%. Okay, I'll give you more example in our next class. I know this is really overwhelming, but the more example that you do, the more that you will understand how to use this. See you next time.